This is Sivakumar, 10th Standard Mathematics, Chapter number 1. Now, exercise 1.4. Before doing exercise 1.4, you must be knowing the concepts of vertical line test, different types of functions, and horizontal line test. Now, you start with the vertical line test. Listen carefully. A curve drawn in a graph represents a function. If every vertical line intersects the curve in at most one point, that means exactly one point. See, using the vertical line test is an example. Determine which of the following curves. 4 curves are given here, 1, 2, 3 and 4. We have to verify whether it is a function or not. How to verify? This is a given graph. That what color it is? Pink color represents a curve. We have to verify whether it is a function or not. There is a vertical line. This vertical line intersects the graph at 2 points, correct? Here one point, here one point. Therefore, it is not a function according to the definition. At most one point means maximum of 1 point. Here the curve cuts the vertical line cuts the curve at how many points? 2 points, therefore it is not a function. Look at the graph. It's a parabola. Here one line, vertical line, here also one vertical line. Don't consider this line because this line lies outside the curve. We have to consider the vertical line intersecting the graph, so that you have to consider this vertical line only. This vertical line intersects the graph at only 1 point. This is a graph. Since the vertical line intersects the graph at only 1 point, it is a function. This graph represents a function. Now look at the third one. It is also a parabola. It is an open up parabola. This one open left parabola. This is a vertical line. This vertical line intersects the given graph at how many points? Here one, here one. So more than 1 point represents not a function. Therefore, it is not a function. This graph is not a function. And the fourth one, it is a graph. This vertical line intersects the graph at only 1 point. So it represents a function. So out of these 4 diagrams, this one, second diagram is a function and the fourth diagram represents a function. First diagram does not represent a function because the line intersects at 2 points. This line, third graph also not a function because the vertical line intersects the graph at how many points? 2 points. So here is the answer. The curves in figure 1.18a and 1.18c, A and C, that is first diagram and the third diagram, do not represent a function as the vertical line meets the curve in how many points? 2 points. So more than 1 point, that is not representing function, remember. Now the curves in figure 1.18b and 1.18d, B and D means second diagram and the fourth diagram represent a function as the vertical lines meets the curve in at most 1 point. Very important. Any equation represented in a graph is usually called a curve. This one represents a curve. This one represents a curve. This one represents a curve. Even this one represents a curve. So we discussed about vertical line test. Now different types of functions. So first one, one-to-one function, many-to-one function, on-to function and into function. We start with one-to-one function. Okay, listen. A function f from a to b is called one-to-one function if distinct elements, distinct means different elements of a have distinct images in B. Look at that example, arrow diagram. This one represents A. A refers the domain, and this one, second set, B represents, let it be A, let it be B. B represents codomain. So what is given here? Calls and friends. Calls represents domain and friends represents codomain. So 1 has the image C, and 2 has the image A, and 3 has the image D. Different elements have different images, therefore it is a one-to-one function. It is also called injection. What it is called? Injection. It's a very important note. If for all A1, A2 belong to the set A, f of A1 equals f of A2 implies A1 equals A2. While working out the problem, you can easily understand. Then f is called one-to-one function. Remember. Next function, many-to-one function. Many-to-one function, here is a definition. A function f from A to B, A represents domain and B represents codomain, is called many-to-one function if two or more elements of A have the same image in B. B represents codomain. Here's an example, arrow diagram. So persons, this one blue color, that represents a domain, and what it is? Films, that represents codomain. Look at that. P1 has an image F1, P6 has an image F1, and even P4 has the image F1. So three elements, what are they? P1, P4 and P6 have the same image F1. So many to one. Understand the concept of many to one? More than one elements have the same image. Okay, even one more. P3 has the image F2, and even P7 has the image F2. Double elements have the same image. P2 has the image F3 and P5 has the image F3. Double elements have the same image. So more than one elements have the same image is called many-to-one function. Next function is onto function. A function f from A to B. A function f from A to B. A represents domain and B represents codomain is said to be onto function. Very simple, if the range of f is equal to its codomain. See, already told you this one represents domain, this one represents codomain. Okay. Now in codomain, what are the elements in the codomain? P1, P2, P3. And range represents what are the elements being mapped from domain to codomain. C1 is mapped to P2, C3 is mapped to P2, C2 is mapped to P1, C4 is mapped to P3, and C5 also mapped with P3. So P1, P2, P3 and all mapped. Codomain P1, P2, P3, range also P1, P2, P3. Both are equal. Therefore, it is an onto function. Another name for onto function is surjection. Okay, already told about that. Injection. What do you mean by injection? One-to-one function is called injection. Onto function is called surjection. Now, into function. Into function definition, here it is. A function f from A to B is called an into function if there exists at least one element in the codomain. B represents codomain, which is not the image of any element of A. Okay, example, here it is. 1 has the image W in codomain. 2 has the image, what is the image of 2? Z in codomain. 3 has the image X in the codomain. But look at that Y. Y has no pre-image. See, image of 1 is W, pre-image of W is 1. You have to say like that. Once again, image of 1 is W, pre-image of W is 1. Like that. Image of 3 is X, pre-image of X is 3. Image of 2 is Z, and pre-image of Z is 2. But that y. Look at that y. Y has no pre-image in the domain. Therefore, it is an example for into function. Codomain. What are the elements in codomain? W, X, Y, and Z. 4 elements are there in codomain. But what about the range? What are the elements being mapped? W, X, and Z. Y is left out. So codomain and range are equal. Codomain has how many elements? 4 elements. Range has only 3 elements. They are not equal. It is an example for into function. Another important note, a function f from a to b is both one-to-one and onto. Both one-to-one and onto. Then f is called a bijection. Bi means two. Okay. For one-to-one, what it is called? Injection. For onto alone, subjection. Both one-to-one and onto is called bijection. Important note. Next, horizontal line test. Already we have come across the vertical line test. Now horizontal line test. Listen carefully. A function represented in a graph is one-to-one if every horizontal line intersects the curve in at most one point. At most means maximum of 1 point. Here 3 examples are there. This line represents a curve. It's a horizontal line. Horizontal line intersects the curve at only 1 point. It is an one-to-one function. Look at that. This is a curve. This is a horizontal line. This horizontal line, this is x-axis, y-axis. This black color line intersects the curve at how many points? 2 points. Therefore, it is not a one-to-one function. This one, x-axis, y-axis, curve, here it is. There is a horizontal line. This horizontal line intersects the curve at only 1 point, exactly 1 point. It is an one-to-one function. Answer is given here. The curve in figure A, first diagram, and third diagram C, represent a function. What's the reason? The horizontal lines meet the curve at only 1 point. Therefore, both the graph represent a one-to-one function. And the second diagram in particular, B, does not represent a one-to-one function because the horizontal line, this horizontal line, black color line, meets the curve in how many points? 2 points. Okay, P and Q. Therefore, it is not a one-to-one function. Understood? Now, some more functions. Listen. We can discuss about constant function, identity function, real valued function. Okay, constant function. Constant function definition, here it is. A function f from a to b is called a constant function. The range of f contains only one element. Very important. Constant function. A function f from a to b is called a constant function if the range of f contains only one element. Look at that example. All the elements of the domain, total 4 elements are there. All the elements have a unique image in the codomain. A, B, C, D. All the elements have the unique image. That is an example for constant function. Now, identity function. Let A be a non-empty set. Then the function f from a to a, look at that, not a to b, a to a, defined by f of x equal to x. For all x belongs to a is called an identity function on a and is denoted by ia. Here, actually here b is given, not b. That should be considered as a only. A to a. A has how many elements? X, y, z. Okay. The image of x is x itself. That's why you are given like that. A to a, image of x is x, image of y is y, image of z is z. So not a to b here, a to a. So each and every element of the domain is associated with itself. Understand the concept? So what is the image of x? X itself. Image of y is y itself. Image of z is z itself. It is an example for identity function. Okay. And the last one is a real valued function. A function f from a to b is called a real valued function. The range of f is a subset of the set of all real numbers, or that is f of a is a subset of the, it is denoted like that, f of a is subset of the set of all real numbers. While working on the problem, you can understand the concept of all the functions, nothing to worry. I'll be teaching that exercise 1.4 in the next video. Thank you, children.